Hello, my name is Mohammed Sarray,
I'm Malik Jawad.
and we'll be presenting about our research about traumatic brain injury and hypoxia and how it produces long-term visual deficits in rats. So our hypothesis is that brain-injured rats exposed to hypoxia exhibit visual deficits that remain or got worse with time. We will be doing the forelimb placing, the landing foot splay, object recognition, visual cliff, and light and dark box tests. Our wave injury for the brain injury model, we use the Marmarou model, and we expose the rats to 30 minutes of hypoxia without oxygen. This is the forelimb placing response. This is the landing foot splay. This is the virtual visual cliff. This is the object recognition test. And this is the light dark box. So for the results for the forelimb placing response, all normal rats raised their head and straightened their forelimbs. All injured rats had a slightly subnormal response. For the landing foot splay, the rats had a wider landing stance after injury that got worse with time. For the virtual visual cliff, injured rats took longer to dismount from the platform than normal rats. All the normal rats avoided the virtual cliff, but 2/3 of the injured rats moved toward the cliff. For the object recognition test, the injured rats take a longer time to explore the novel object. For the light and dark box, rats at 5.5 months after injury took longer than rats at 3.5 months after injury to move to the dark box.
The conclusions show that for the forelimb placing test, slightly abnormal response of the injured rats suggests that the rats did not see the landing well. For the virtual visual cliff, the rats took longer to dismount, and that may be due to the impaired brain processing. Most of the injured rats moving to the cliff to dismount suggest that the visual deficits are present in the injured rats. For the object recognition, rats took a longer time to explore the new object and that were injured than the normal rats due to the visual or memory deficits. This didn't change with increasing time after injury. For the landing foot splay, the rats had a wider landing stance after injury. Wider stance means greater stability. At longer times after injury, the stance even got wider due to increased visual deficits and balance problems from the head injury or size. For the light and dark box test, the injured rats took longer time to enter the dark box than the first child. The rats at 5.5 months after injury took even longer than the rats after 3.5 months after injury. Loss of sensitivity to light might relate to a continuing death of the retinal ganglion cells. In all of our functional tests, the injured rats performed worse than the normal rats. In the landing foot splay and light-dark tests, rats with longer time after injury did worse than rats with less time after injury. This may show that the continued loss of retinal ganglion cells. Our findings support brain-injured rats exposed to hypoxia exhibit visual deficits that remained or got worse with time. Thank you.